Okay, so how do we find absolute, which are also called global extrema? We know that they occur at critical points and at endpoints. All right, so here's an example. Let's suppose f of x is equal to x squared times the square root of x plus 4. Okay? So the first thing I'm going to do is I need to find the critical points, and let's say it's on the interval, let's say on the interval 1, 5. Okay, I just made that up. So let's suppose we want to find the absolute max and the absolute min. Okay, so find the absolute max and absolute min of f of x on 1, 5. Okie dokie. So what do? Well, I know that they occur at critical points and at endpoints. I know my two endpoints, so the first thing I need to do is I need to find my critical points. Okay, now I'm going to do a little cheat here. I don't feel like using the product rule, so I'm going to use the fact that x squared is equal to the square root of x to the fourth, which means that f of x is equal to, I'm going to switch sides here, f of x is equal to the square root of x to the fourth times the square root of x plus 4. And now since they're both under a square root, I can multiply through, and it saves me having to use the product rule. So I get the square root of x to the fifth plus 4x to the fourth. All right, now I'm going to take the derivative. So again, this is f of x. I take the derivative. So f prime of x then is 1/2 x to the fifth plus 4x to the fourth to the negative 1/2 times the derivative of the inside, 5x to the fourth plus 16x cubed. Okay? So now if I simplify this, I get the 5x to the fourth plus 16x cubed in the numerator. I'm going to factor out an x cubed there. So x cubed times 5x plus 16 in my numerator. And in my denominator, I have 2 times the square root of x to the fifth plus 4x to the fourth. Now remember, what I did is I put this extra x to the fourth in there, so I'm going to pull that out. So my derivative now is x cubed times 5x plus 16 over 2x squared. I factored an x to the fourth out of here and then took the square root times the square root of x plus 4. Okay? Again, doing this little trick up here just saved me having to do the product rule, and I didn't feel like doing the product rule. So now I can cross out all these, and I'm left with an x up here and a 2 down here. So my critical point, set your numerator equal to 0, your denominator equal to 0. My critical points from my numerator, x is 0, x equals negative 16 over 5. I wrote the wrong number down. I was supposed to write a 3 here, and then it works out really nicely, but I goofed. And then x plus 4, so negative 4 is a critical point. So I have 3 critical points, all right? And I need to check my critical points here and my endpoints. Whatever has the biggest y value is the absolute max. Whatever has the smallest y value is the absolute min. Alrighty, so part 2, and I think I can write this here and you can still see it. Part 2 is check your critical points and endpoints in your function. Okay? So I need to know what f of 1 is 1 squared times the square root of 1 plus 4 is root 5. F of 5 is equal to 25 times the square root of 5 plus 4, which 5 plus 4 is 9, the square root of 9 is 3, so this is 75. Okay, f of 0, that's a nice easy one, that's 0. F of negative 16 over 5, I think I goofed here. Hold on one second. Let me just make sure I didn't goof. 4x to the fourth, 16x cubed. No, okay. Negative 16 over 5. This is a little bit of a pain, but we can do this. So if I plug in negative 16 over 5, I'm going to get 16 squared over 25 times the square root of negative 16 over 5 plus 4. This is 20 over 5. Okay, so this is equal to, I think 16 squared is 256. 256 over 25 times the square root of 4 over 5. I'm going to just go pull out my calculator. Here we go. If I pull out my calculator here, I have the square root of 250, I'm sorry, clear that off. I have 256 divided by 25 times the square root of 4 over 5, and that gives me 9.2. Okay, and if I plug in negative 4, f of negative 4, well, x plus 4, when you plug in negative 4, it's just going to be 0, right? I'm going to have 16 times the square root of negative 4 plus 4, so that's 0. So now I just look, okay, this is my smallest, so I have an absolute min. Oops, you can't see that there. Right where you can see. So this is my smallest. So I have an absolute min. Hold on, let me just adjust. There we go. Absolute min of 0 at x equals negative 4. My biggest y value is 75, so I have an absolute max of 75 at x equals 5. And boom, I'm done.